In the last example, we graphed a function where the base a was greater than 1 and identified characteristics of that graph. Now let's graph a function where the base a is between 0 and 1 and identify characteristics of that particular type of graph. We're going to graph f of x equals 1/2 to the x power. Again, the method we're going to use initially is the point plotting method. So I've selected values of x at which I'm going to evaluate my function. So we start with f of -10. That's going to give me 1/2 to the -10 power. 1/2 to the -10 power is 1,024. 1/2 to the -3rd power is 8. 1/2 to the -2nd power is 4. 1/2 to the -1st power is 2. 1/2 to the 0 power is 1. 1/2 to the 1st power is 1/2. 1/2 to the 2nd power is 1/4. 1/2 to the 3rd is 1/8. 1/2 to the 10th is 1/2 to the 2nd power, which is about 0.00098. So now what we're going to do is take a few of these points and graph them in a Cartesian plane to see if we can't ascertain some of the characteristics of the graph of an exponential function, f of x equals a to the x power, where a is between 0 and 1. So I start by graphing the point -3, 8, which is way up here. So we'll just throw it way up there. Then we have -2, 4, 1, 2, 3, 4, -2, 4. Then we have -1, 2. And then we have 0, 1. And then they get tiny. 1, 1/2. 2, 1/4. 3, 1/8. Blah, blah, blah. Now, we connect the points into a smooth curve, or at least we try to. And here we go. That's not too bad. And now, what we need to do is figure out some of the characteristics of this particular graph. Again, we're graphing here f of x equals 1/2 to the x power. So the characteristics that I'm going to talk about right now are characteristics of all exponential functions where the base a is between 0 and 1. In other words, a fraction between 0 and 1, or a real number between 0 and 1. All right, here we go. What do we notice about the domain? We should notice that the domain is the set of all real numbers. What about the range? We should notice the range is all positive real numbers. What else do we notice? Are there any x-intercepts? No x-intercepts. How about y-intercept? Notice there's a y-intercept at 1. So the y-intercept is always going to be 1. What else do we know? Well, look at what happens as x goes to positive infinity. As x goes to positive infinity, the graph gets closer and closer to the x-axis. That is, y equals 0 is a horizontal asymptote as x approaches positive infinity. Okay? Now what else do we notice? Well, we should notice that the function is a decreasing function. And because it's a decreasing function, the function is 1-to-1, which means it's going to have an inverse function.